The next type of chart I want to discuss is a Pareto chart. So this is a bar graph where the bars are arranged in frequency order, okay? You're only going to want to do this for nominal data, right? If I did this for ordinal data, that's qualitative data with a specific order, right? A rating scale or good, better, best. It wouldn't make a ton of sense, right, to rearrange that data. So this is only for nominal data. Oh, and I said that, so good. Now we double know. So for which of these graphs would be a Pareto chart? So here we have the 5 largest cities in the United States. This bar has the bars in alphabetical order, which is a totally justifiable way to arrange them. And then over here we have them in the descending order from largest. I had no idea Houston was that big. So this would be the Pareto chart. We could also use pie charts. Pie chart is a circle where each wedge represents the relative frequency, so it's really good we were able to calculate the relative frequency. You can also make these in Excel, and the entire pie represents the total relative frequency of 100%. So here we have an example with favorite movie types. Next, we have histograms. So a histogram is a bar graph for quantitative data. It can be for interval or ratio level of measurement. It's up to you. And the bars have a natural order, and they need to be attached, okay? And the bar widths have specific meanings. So for example, here we've got a difference of 5 feet between every meeting. This is between every bar. This is a great example of a histogram. Here we have the heights of black cherry trees. We've got our X and Y axis labeled, and our scales are labeled clearly as well. That's really important. One thing that's nice when we're using quantitative data, you need to put the units. Height in feet, height in inches, years in decades, years in centuries, temperature in Celsius or Fahrenheit. So you need to be sure you put the units. Units are crucial. Crucial. Spelling. Again, math teacher. So let's make an example of a histogram. So here are the following ages of 10 participant siblings. We've got 11, 23, 27. I'm not going to read them all. The first thing we need to do is create a frequency table with bins and then with different bins and then a histogram. So this would be really boring of a histogram if we did ages, say like 10 to 19 and then 20 to 29. We should probably break it down a little bit smaller. So I'm going to do 5s. I'm going to do 10 to 14, 15 to 19, 20 to 24, and 25 to 29. So I have 1, 2, 3 participants between 10 and 14, 2 participants between 15 and 19, 3 participants between 20 and 24, and 2 participants between 25 and 29. I can then use this information to make my histogram. So I need to label my axes. This is like age of siblings, age, I'm going to go ahead and label it years. I don't know. When kids are little, they say like 18 months. I don't get it, but somebody does. Okay, we've got 1, 2, 3. That's my highest frequency. We've got the frequency on the left here. Frequency. Okay, so I have from 20, 25. Oh, I started it wrong, right? They're 10. It starts younger than that. Okay, so I've got 10, 15s. Notice that each bar is going to start at the first value of our bin, 20 and 25. So from 10 to 15, from 10 to 14, I've got 3. From 15 to 20, I have 2. From 20 to 24, I have 3 again. Again, notice my bars are touching. The width matters. You can make these in Excel as well. And then for 25 to right before 30, I have 2. So here would be our histogram. The last couple of graphs I'm going to talk about are line charts and stem and leaf plots. So a line chart shows the data value for each category as a dot, with the dots connected by lines, okay? For each dot, the horizontal position is the center of the bin it represents, and the vertical position is the data value for that bin. Time series diagrams are a histogram or line chart in which the horizontal axis is represented by time, right? So that means not age per se, but years. This is really common in presenting economic data, unemployment data, things like that. The last thing I'm going to talk about is a stem and leaf plot. This is somewhat like a histogram turned sideways, except in place of bars, we see a listing of the data values. So here's a stem plot for the ages of Academy Award-winning female actors. You can see that most of the people were in their 30s. We had very few people in their 70s or 80s. So we can kind of see it is a histogram turned sideways. So let's practice making one. What we do here is the stem is the first digit, and then the leaves are every digit after that. So let's make an example. Let's say I want to make a stem and leaf plot for the following data set. So these are the ages of 10 participants' siblings. 20 was too much. I decided to make it just 10. These are the ages of 10 participants' siblings. We've got 11, 23, 27, 13, 14, 18, 29, 15, 20, and 22. We're going to take our stems. Those are going to be the tens, or the first digit, right? So I have 2 stems. I've got 1 and 2. And then we're going to have our leaves. So we want to put these numbers in numerical order. So I've got to look at all of my ages with a 1 as the first digit. So I'm going to have 11, 3, 4, 5, 8. So 1, 3, 4, 5, 8. For 2, I've got these guys. Let's do them in blue. So I want to put those digits, those second digits in numerical order. I've got a 0, a 2, a 3, a 7, and a 9. So that's how we make a stem and leaf plot. I did include the solution to that as well.